In this video, we will expand some binomial expressions of the form x plus y to the n. So we assume that x plus y to the n, then its expansion using the binomial formula is given by x plus y to the n, nc0 x to the n plus nc1 x to the n minus 1 y to the 1 up to so on dot ncn y to the n. So we have proved it earlier. Now we will put different values of n and different values of x and y, and we will check what kind of expressions we are getting. So first put n is equal to 0, you will get x plus y to the 0. You know anything to the power 0 is 1. Okay, let's do the same thing for n is equal to 1. So we get again very simple case, which is x plus y. So let's do the same thing for n is equal to 2. You will get 2c0 x to the 2, 2c1 x to the 1, y to the 1, then 2c2 x to the 2 minus 2, which is 0, y to the 2. You will get x square plus 2xy plus y square. So put n is equal to 3 instead of 2, you will get 3c0 x to the 3, then 3c1 x to the 2y, then 3c2 x to the 1 y to the 2, then 3c3 x to the 0 y to the 3. So after simplifying, we will get x cube, then 3x square y, then 3xy square, then y cube. So what will happen if I put n is equal to 4? I will get 4c0 x to the 4, 4c1 x cube y, 4c2 x square y square, 4c3 x y cube, 4c4 x to the 0 y to the 4. I'll get x to the 4 plus 4x cube y plus 6x square y square, 4xy cube plus y to the 4. You can see one thing is very important in all of these expressions. You can see here we have maximum power of x. Here we have one reduced power of x, and we start from y. Then again reduced one more power of x and increase one more power of y. Again we have reduced one more power of x and we have increased one more power of y. So we have to do it until we get the maximum power of y. Here n maximum is 4, so we have to do it until we get 4. So this thing is very common in all of these expressions. You can see here you will get the same thing. You can see here you will get the same thing. And in all expressions coming after this, you will get the same pattern. So what about the coefficients? Here you have 1, here you have 1. Here you have 4, here you have 4, here you have 6. You can check these coefficients are symmetrical if you start from left or if you start from right. You will get the same sequence of the coefficient, because here you are getting 1 4 6 and here you are getting from right 1 4 and then 6. So you can see this is symmetrical from both sides. It is not happening with this case. You can see it is the same thing with this case as well. Coefficients are 1 3 and here 1 3. Again, these expressions are symmetrical from both sides, from left hand side as well as from right hand side. So if I am able to find all of these coefficients, then I can easily get any kind of expression of binomial theorem. So in order to find all of these expressions, let's make a Pascal triangle. In the Pascal triangle, we will write the coefficients of n in each row. So for n is equal to 0, we have only one coefficient, that is 0c0. But for n is equal to 1, we have two coefficients, 1c0 and 1c1. For n is equal to 2, you have 2c0, 2c1 and 2c2. For n is equal to 3, you have 3c0, 3c1, 3c2, 3c3. So in this way you will get all of these expressions. Now let's make a Pascal's triangle. Now we are going to make the Pascal's triangle from the above data. So let's see how to construct it. So on the top you will write 0c0. This is for n is equal to 0. Then you will write for n is equal to 1. The first coefficient is 1c0 and the second coefficient is 1c1. So for n is equal to 2, you will get 2c0, then 2c1, then 2c2. Okay, for n is equal to 3, you will get 3c0, then 3c1, then 3c2, then 3c3. Look at one more expression for n is equal to 4. You will get 4c0, then 4c1, then 4c2, then 4c3, then 4c4. Then you will carry on this process. We can generalize this triangle for n is equal to arbitrary k. But now I am interested to find these values. 0c0 is just 1. This is 1. This is 1. But interestingly, you can see the relation of these triangles. This triangle, then you can see this triangle. You can also see this triangle. Here we have another triangle. This is also a triangle. This is also a triangle. So all of these are triangles. That's why we call it Pascal's triangle. Now we are interested to relate the coefficients which are lying in these triangles. So you can see these triangles. First you can see the blue triangles I have written down here, then red one, then all of these we have written down here, you can see. So in the first blue triangle you can see we have 1c0, 1c1 and 2c1. So I've told you a formula before couple of videos that n minus 1 cr minus 1 plus n minus 1 cr is the same as ncr. You can see here is 1 less than n, here is 1 less than n. We have added 1 here. Here is 1 less than r and here is r. So from these two we have picked the bigger one, which is r, and from these two we have added 1. You can see from these two elements 1 and 1, we have added 1 here, and from these two we have taken bigger one. So you can see this formula is going to be valid in all of these triangles. You can see here we have added 1 in 3, you can get this, and from these two we have picked the bigger one, which is 1. So the same thing is happening in this triangle. We have added 1 in 3, you can see here, and we have picked the bigger one, which is 3 here, you can see. The same you can see in this triangle. We have added 1 in 2, which is this, and we have taken bigger one from these two, which is 1. And similarly 2, here is 2, we have added 1, and from these two we have taken bigger one, which is 2. Again here we added 1, which is 4, and we have picked the bigger one, which is 2. So in all of these triangles, you can see here in the Pascal's triangle, we are getting the next term, which is the sum of previous two terms. So this is the sum of previous two terms. This is also the sum of previous two terms. So therefore, the construction of Pascal's triangle becomes easier to understand. So here we have 1, 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 1, 1, 1, 1, dot, 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 dot. Here we will write the sum of these two, which is 2. This is the sum of these two because it's making the same triangle. Okay. Here we write the sum of these two, which is 3. You can see this is making a triangle. Okay. Here we write the sum of these two, which is 3. Again, this is making a triangle. Here you will write the sum of 1 and 3, which is 4, because this is again making the Pascal's triangle. Here you will write the sum of these two, which is 6, because this is again a Pascal's triangle. It is the sum of 3 and 1, which is 4, because it is again a triangle. So in this way you will carry on this process. So what will be the next term? Here you will write 1, here you will write 1, here you will write the sum of 1 and 4, which is 5. Here you will write the sum of these two, which is 4 plus 6, which is 10. Here again you will write the sum of these two, which is 10. Now again you will write the sum of these two, which is 5. So we have completed this line as well. So in this way we can carry on this process. This triangle is called the Pascal's triangle. Now we will verify our binomial coefficients. I will check whether this triangle representing the same binomial coefficients which I have discussed earlier. I mean to say, I will check whether the first row corresponds to n is equal to 0 or not. And this row corresponds to n is equal to 1. This row corresponds to n is equal to 2. Then n is equal to 3, up to so on. So I will check, I will verify. So for n is equal to 1, you can see x plus y to the, sorry, not n is equal to 1, n is equal to 0, x plus y to the 0, which is 1. So we are getting the first coefficient, which is 1. So no problem. Let's do for n is equal to 1. We have to do x plus y to the 1, which is x plus y. So the first coefficient is 1. Second coefficient is also 1. Here we have two coefficients which are 1 and 1. So we have no problem. So for n is equal to 2, you know, we have verified, we have found the binomial formula that is x square plus 2xy plus y square. Here you have the coefficients 1, 2 and then again 1. So for n is equal to 2, we have these coefficients 1, 2 and 1. So again, we have no problem. Okay, for n is equal to 3, what's going on? X plus y to the 3, this is x cube plus 3x square y plus 3xy square plus y cube. So we are getting the coefficients 1, 3, 3 and 1. So you can see here 1, 3, 3 and 1. So let's do for n is equal to 4. X plus y to the 4, which is x to the 4, 4 times x cube y plus 6 times x square y square, 4 times x y cube plus y to the 4. So we are getting 1, 4, 6, 4 and 1. So let's check we have the same coefficients or not. So you can see we have 1, 4, 6, 4, 1. So this Pascal's triangle helps us to find the coefficients of the binomial expression. This is very interesting because we have made it very easily and we are getting all of the coefficients of binomial expression for any n. So I'm going to assign you one thing. Find the formula for x plus y to the 10. But without using binomial theorem, you have to use only Pascal's triangle. So if you solve this exercise, then you are able to do everything which I have done in this video.